Gonna start back just reminding ourselves what the three forms of quadratic equations are. We have the vertex form, the second one is the standard form, and the third one is the factored form. We started out with quadratics with this standard form, y equals some number a times x squared plus b times x plus c, and then we factored this to get the factors of the standard form. And then we also see it in vertex form. Let's look at vertex form for just a second. Vertex form is the form where we can actually take this h and this k, pull it right out of the equation, put it in parentheses, and plot our vertex in the form of the x and y value. This x and y value would be the coordinate for our vertex, and so it would look like this. It would be, h, k, where h is the x coordinate and k is the y coordinate of our vertex. And then on from there we had the standard form, which is what we're very used to seeing. C, the only thing we can get right off without doing some work is the y-intercept. So from the vertex form we can get the vertex. From the standard form very easily we can get the y-intercept, or the place where the graph crosses the y-axis. And then finally from the factored form we can get the zeros, or the x-intercepts, or we also call them the solutions to the equation. The roots are another name. This point P and point Q would be the x values where the parabola crosses the x-axis. And then finally, let's continue to remember that A determines the way the graph opens. If A is negative, then the graph opens up, and if A is positive, the graph opens down. So if we have a negative A, we're going to have a graph that opens down like this, a parabola. If we have a positive A, it's going to open up. It's going to open up. So negative, we flip our cup upside down and all the water pours out. That's a negative thing. Positive, we hold the cup upright and it holds our water. That's a positive. Okay, let's go on to the next page. You need to be able to recognize the different forms of these quadratics. On the left, we have the vertex form. We can easily get the vertex. The vertex form is y equals a times x minus h, quantity squared, plus k, where h and k are the x and y coordinates of our vertex. So this is the vertex form. Remember, h and k are our x and y coordinates of our vertex. On the right, we have the factored form, or we can also call it sometimes the intercept form. We get our factors, or our zeros, or our roots from this form. For example, in this equation, x would be equal to 4 and x would be equal to negative 1. That would give us our intercepts of 0, 4, and 0, negative 1. We also call these the roots, the solutions, etc., etc. And that is our factored form. It's where it crosses the x-axis. This form here, this one is sort of in disguise, I think. A little disguise on this guy, because it really is the intercept form. It's the intercept, the the intercept form. I'm having a little trouble here writing on this guy. So this is the intercept form, where if you remember, intercept is y equals some number a times x minus h squared plus k. Well, we don't have an h. So it would just kind of look like this. Y equals some number a times x all squared plus 4. So we do get the it's actually not the intercept form at all. It's not the intercept form at all. It's the vertex form. And I think I messed that up on the first one. We have the vertex form. And from the vertex, our vertex form is y equals a times x minus h squared plus k. Up here we don't have an x minus h. H would just be 0. So this is 2 for an a times x minus 0 squared plus 4. So we get the vertex from this. The vertex would be at 0 because there is no h. But there is a plus 4 out here. 4, that's our vertex. Over here we have, this again is going to be this is not vertex form. This is actually factored form. It sure is factored form. How is that factored form? Well, because our factored form is y equals a times x minus p times x minus q, where p and q are our x-intercepts. But on this guy, it gets a little tricky. On this guy we have oops. On this guy we okay, hang on. We have y equals -4 times x plus 6 times x plus 6. X plus 6 squared is x plus 6 times x plus 6. So this is actually our factored form. And from here we can get our x-intercepts. And this would actually have just one solution at x equals -6. So our x-intercept would be 0, 6, 0, 6. The vertex would be sitting on the vertex of the parabola would be sitting on the x-axis, facing down at the point 0, 6. What form do we have here? Well, this is the standard form. The standard form. Okay. And this is the old y equals ax squared plus bx plus c. The information we can get here is the y-intercept. The y-intercept. And that's going to be my 8 here. My 8 here. My 8 is going to intercept the y-axis. Let's see. Intercept is going to be 0 has to be the x value, and then it would be a 0, 8. That's my y-intercept. Okay. And it's going to open up. There's a few other things, but that's what we can garner quickly from the standard form. Now here we have, what form would this be? It looks like the vertex form to me. The vertex form to me. Okay, so this is the vertex form, and we have the vertex form as y equals a times x minus h squared plus k. You have to be careful because you could really call this the factored form if you wrote it as y equals x minus 6 times x minus 6. But you got that plus 1 out there. So, you know, is it the factored form? Not really, not really. This is definitely the vertex form. And from this guy we're going to get the information of the vertex. The vertex is at, remember, it's h, which would be 6, k would be 1. Notice how this sign here changes here. We don't pull the -6 down here because all we want is the 6 out of here. We just want the 6 out of here. The positive does stay with the 1 though. Okay. Let's keep going forward. What do we have here? Well, on this guy, this actually is the factored form. This is the factored form. Because if we put this thing together, if we distribute this thing back, it's been factored. Because if we distribute this thing back in here, we would get 2x squared plus 6x plus 0, and that's our standard form. That's our standard form. So really, somebody took the standard form and they factored it, and this is what they came up with. So we're good on that right there. Let's change pen colors here and see what we can do with it. The information we get from the factored form are the x-intercepts. Now the way we get the x-intercepts here is we would set x equal to 0. Okay, and then we would solve for the other one by setting this factor equal to 0. Okay, so we end up coming up with the solutions, or the places where it crosses the y-axis, are going to be at 0, 0. Okay, these are the x-intercepts. And I have to take this 2x plus 6 and make it equal to 0. Subtract 6 on both sides. 2x equals negative 6. Divide both sides by 2. X equals negative 2, 4, 6, negative 3. So our other x-intercept would be at 0, negative 3. 0, negative 3. And that's what we did there to find the 0 for this factor. So they can get a little tricky. They're not always super straightforward. Okay. And what are we going to do with this guy? Well, what form is that? Again, this is the factored form. But we can do a little more factoring on this guy, could we not? I mean, we could rewrite this as y equals, and we can take a negative 3 out of here. Negative 3 times, and let's watch what happens with this thing. X minus or plus 3 times x plus 4. So we've rewritten this and we've factored it out further. We factored a negative 3 out here. Now we have a pure factored form where we can find our x-intercepts. And our x-intercepts are whatever would make this factor 0 and whatever would make this factor 0. Remember, it's our p and our q. So we're going to have a negative 3, right? So that it would be at negative 3, 0, and the other one would be at negative 4, 0. Uh-oh. My pen quit on me. Negative 4, 0. That's not a 10 there. Let me touch that up a little bit. Okay, that is, it looked like a 10, but it actually was a comma, negative 3, comma 0. I'm still a little rusty at this, using this this writing feature here, but that's what we get from here, our x-intercepts. Let's keep going. Let's create a equation. Negative 5, 3 and opens down. Well, we should use let's use vertex form. Why not? We'll use vertex form. Vertex form is y equals a times x minus h squared plus k. So if it opens down, we've got to have a negative a. We've got to have a negative a. So let's call this, I don't know, y equals negative 2. That'll give us a negative a times x minus, well, we got to put an x plus 5 because this, if we're going to have a negative 5 for a vertex, remember the sign changes for the x value, and a positive 3 plus 3. So this opens down because our a is negative, and here's our vertex, negative 5, positive 3. Okay? How about b? X intercepts at 3, 0 and negative 5, 0 and opens up. Well, let's use intercept or factored form. Okay, And remember, our intercept or factored form is y equals a times x minus p times x minus q, where p and q are our x-intercepts. So let's just make us up a problem here. We want it to open up, so I have to have a positive a. Let's make a 2 again, positive 2, x minus, and we want this to be a 3. So we put x minus 3, and we want this to be a negative 5. So minus the negative would make this a plus 5. Opens up, and our intercepts are 3 and negative 5. Let's use standard form. Let's use standard form, because standard form gives us our y-intercept. And standard form is y equals ax squared plus bx plus c, where c is our y-intercept. But to open down, a must be negative. A must be negative. So let's write this guy. Let's just use negative 2 again. How about it? Negative 2x squared plus, oh, I don't know, 5x plus 7. Alright. And in the next one we have x-intercepts. So let's write an equation that has these two x-intercepts and opens down. Well, if we're going to do that, we need to use intercept form. Y equals a times x minus p plus x minus, or times x minus q. And to open down, a must be negative. So let's use y equals negative 2 is always easy. X minus 0. X minus 0 means it would just be 0. So let's just call it x. And then the other one will be x minus 2. X minus 2. So you see how this is a, oops, this is a 0 and a 2, because 2 minus 2 would be 0. And it opens down. And finally, on our last row here, we'll plot these. How about we plot these over on Desmos, just to see if they work. The vertex, let's use vertex form. Vertex form is a times x minus h squared plus k, where h and k are our vertex. So for the equation part of this thing, let's go with y equals, it's going to open down, so a has to be negative. How about negative 2? Yeah, negative 2 times x minus, since it's a negative x, we have to change this to a positive 3. And with the y value of the vertex being 0, we'll just leave this. We don't have to put plus 0. We'll just leave the plus 0 off. And let's see, vertex at negative 3, 0 and opens down. Let's go over to Desmos and plot this and see if the vertex is at negative 3, 0 and opens down. I got Desmos pulled up right here. And we said y equals 2 times x minus, or was it x plus 3 quantity squared. And we said we could put a plus 0. It doesn't change anything. We can take the plus 0 off. And let's go back over just to double check. This should have a vertex at negative 3, 0. Oops. And it does. Our vertex is right here at negative 3, 0. Uh-oh. But ours is opening up, and we want, oh, I forgot the negative in front of the 2 to make it open down. So put a negative in front of the 2, and look at that. It opens down, and the vertex is indeed at negative 3, 0. So we're dancing. That's a good one. Now let's go back over and do this last one, and we'll plot it on Desmos again. Y-intercept at 0, negative 2, and opens up. Well, the y-intercept form is y equals a times x minus h squared plus k. Ooh, actually, I take that back. That is our vertex form. And we do not want to use that. We want to use standard form. We want to use standard form for our y-intercept. So we're going to have y equals, standard form is ax squared plus bx plus c. And the only thing we're going to know is that our standard form, our c value, is our intercept. our y-intercept. So we want it, it's going to open up. So I don't know, let's make this let's just leave it as, let's make a equal to +1. So that would give us x squared plus, how about 2x plus, well, we're going to have to make this plus a minus. That's got to be negative right there. So 1x squared plus 2x minus 2. Let's go plot this on Desmos and see that the x-intercept is at 0, -2, and it opens up. X squared plus 2x minus 2. So y equals x squared plus 2x minus 2. And boom. Our vertex is at 0, -2. And if we flip back over here, yep, 0, -2. And it does open up. So we're good to go. And there it is over there. Alright, well that does it for this first video. Please come on back for the second video where I'll be converting different forms to different other forms for you, which will be a necessary skill for Algebra 1. I hope everybody's safe, healthy, has plenty to eat. Anything I can do for you, please let me know.